Good morning, Kim 2. Today I want us to walk through what's called a radioactive decay series. I went over in the last video the 5 types of radioactive decay. In a radioactive decay series, we're going to be primarily focused on alpha particles and beta particles. And this is how they occur in nature, and we can look at this series. There's all kinds of series. I want to show you one starting with thorium. And it's thorium-232. Now, thorium-232 will go through an alpha decay. Remember, alpha decay is a helium nucleus, so it's going to lose 4 in terms of atomic mass, and it's going to lose 2 in terms of atomic number. And you look on the periodic table, and you see that that is radium. Now, radium then will undergo a beta decay. And remember, beta decay is when a neutron is able to eject a beta particle, like an electron, from its nucleus. And that ends up, basically, the mass stays the same, but then the atomic number increases by 1. And that gives us actinium. Then actinium also goes through a beta decay. So again, we go 228, the mass doesn't change, but then the atomic number increases by 1. So now we're back to thorium. Now in this case, we're going to have a whole bunch of alpha particles in a row here. So thorium undergoes alpha decay. So 224 and 88, which we know is radium. Notice I try to keep those on the same line, just because they have the same atomic mass. You'll see that often in decay series written that way. Okay, then we have another alpha decay, and again 224, so we have 220, and then we have 86, and if you look in your table, you see that that is radon. Radon goes through an alpha particle emission, which of course gives us in 216 and 84, and that is polonium. And then polonium also goes through an alpha, which now gives us 212 and 82, and we see that that is lead. Now this is lead, that is a radioactive isotope of lead, and so it's going to also continue to break down. And what we see happening here then is we have, sorry about that looking kind of funky, a beta particle, so the mass stays 212. The atomic number goes to 83, and you see that that is bismuth. And then bismuth also goes through a beta breakdown, which gives us 212, and now we're back up to 84, so we're back to polonium once again. And then polonium goes through an alpha breakdown, so now you're at 208 and back to 82, which we just said is lead, but now we have a stable nucleus. And so this is the breakdown as we see occurring in nature. Now we can monitor the times for all these. We haven't really got into all of that with you in terms of half-life, but I found this table here, so let me just share this with you. As thorium goes down to radium, it's 1.4 times 10 to the 10th years. Radium to actinium is 6.1 hours. Actinium to thorium is 5.7 years to go to here, 6.1 hours to here. Thorium, 1.9 years to get to radium again, and then it takes 3.6 days to go to radon, 55 seconds to go to polonium, 0.14 seconds to go down to lead here, 61 minutes to bismuth, or excuse me, 10.6 hours to go to bismuth, 61 minutes to go to polonium, and it's 10 to the negative 7 seconds almost instantly, then it goes to stable nucleus of lead. So this is a radioactive breakdown series, a decay series they're called. I'm going to put one of these on the worksheet that I want you to do, and basically you're going to take a radioactive isotope, like say thorium, and bring it down to a stable. So I'll say you want to go from here to here, and then you have to figure out, do I go alpha particles, beta particles, and I don't expect you to have them exactly right in terms of alpha, beta, beta, alpha, 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 beta, beta, alpha. You're just going to see that this takes 1, 2, 3, 4, 5, 6 alphas and 1, 2, 3, 4 betas. And so all of you may have a different answer for this, and that's fine. But I want you to be able to show how you go from one isotope to another isotope over a series of steps. And so that's going to be one of your homework questions I'm going to have on that. Probably give you 2, and then there'll be 1 on the test. And that test will be sometime next week. I'm trying to wrap all this nuclear stuff up before spring break. I hope all this is going well. I know you may not know this, I've said it before, but this is something I absolutely love to teach. I love teaching nuclear chemistry. I love looking at the nucleus and answering your questions on that. And so this is what we have to do for now. You know, we're all doing as best we can. Hope these videos are helping. If you have questions, please email me questions. If you would find it be helpful if we did a Zoom video, let me know, or a Zoom meeting time. I did that with AP yesterday, and it worked out fairly well. I know all of you probably couldn't be involved, but if some of you want to be involved and want to set that up, I'd be more than willing to do that, try to answer some of your questions. So I hope this is going well. Hope you're enjoying your time as best you can. I know this is a crazy situation we find ourselves in, and obviously I want to get back to normal as soon as possible. Miss you all a great deal, and just looking forward to this being behind us. So take care, and we'll talk to you later.